So these last couple of lessons, we've been working on all these different types of transformations, right? We've been working with reflections, we've been working with translations, we've been working with dilations. Today we're going to work with the last type of transformation, which is a rotation, right? And so again, we've gone over the basics of all of this, but when it comes to rotations, we know that another word for rotation is turn. Think of it almost as a wheel all the time. Whenever we're rotating any object, we are literally turning to the left, to the right, all of that. But what we're going to figure out when it comes to rotations is you don't specify whether you're turning it to the left or turning it to the right. There are two different directions that we refer to when it comes to discussing rotations, right? When we look at it, because again, a rotation is a turn. Whenever we're looking at it as a turn that's going this way, right? So it's curving along towards the right, again. So when we're turning an object this way, it's what we would refer to as clockwise. And the reason that we call it clockwise is because you're literally turning an object the direction of the clock. Because when you read a clock is always going this way, right? Where it's 1, 2, 3, 4, 5, 6, so on, right? So that's clockwise. So now we think, if this rotation is clockwise, the opposite rotation, instead of going the way a clock would, it would be the opposite way that a clock goes, right? And when you're thinking about the opposite way that a clock goes, that's something that we call counterclockwise, right? And it's called counterclockwise because it's going the opposite way of a clock, right? So we have clockwise, which goes the way of a clock. We have counterclockwise, which goes the opposite direction of a clock. And the reason that this is so important is because this is what we're always going to use to be able to describe different types of rotations, right? Clockwise and counterclockwise. And again, we will go into this, but just remember, just to begin with, clockwise goes in the direction of a clock, typically towards the right at the beginning, and then counterclockwise goes the opposite way of a clock, typically towards the left at the beginning, right? And so when we're talking about rotations, right, we're going to look at a graph, right? And let's say that we have, let's give you this triangle here, right? We have a triangle right there, and then we are going to have a triangle that looks like this, right? I'm going to highlight this point right there, and we're going to highlight this point right there. Let's call this one F. Let's call this one F prime, right? And now again, the one thing you got to realize, even though my drawing looks horrible, okay, let me try to fix this so it looks perfect for you guys, just so people don't start having ideas about it changing. Since it's a rotation, the size should not change. It should stay isometric, right? The size should not change whatsoever. The only one that the size ever changes for is the dilation, right? So when we have this, we're going to end up analyzing this because when it comes to rotations, there's something that always happens when it comes to the degrees, right? Whenever it comes to analyzing what the coordinates are going to be. But even before that, let's analyze what's happening with the directions, right? So we see this. We know that this is where we're starting. We know that this is where it's being rotated towards. And we know that because of the prime. Always remember, prime comes last. The term without the prime always comes first. The one that comes first is always our pre-image. The last figure is always our image, right? Again, image always has the prime. So we know that if we wanted to actually describe this rotation, we're seeing that it's going from here to there, right? So if we're seeing that it's going from there to there, we know that it's going that way, right? So again, a few things that are happening. In order to describe a rotation, there are always two things that you need. You need to know how many degrees, and you need to know what direction, right? And direction, again, should be pretty easy in terms of looking at it, but it's degrees that we need to figure out. Because when we look at a graph as a whole makes a circle, right? All of these together. We know that a full rotation, a full turn is going to make a circle. That full circle always adds up to 360 degrees, right? Every single circle adds up to 360. So if we're talking about a rotation, we have 4 quadrants on the graph, right? 1, 2, 3, 4. And then if you want to look at it this way, always look at it as almost like every single quadrant is 90 degrees, right? So this would be 90. Let me write these in for you to see it. This would be 90, right? This would be 90. This would be 90. This would be 90. Every single quadrant is always 90. And when we add them up, 90 plus 90 plus 90 plus 90 gives us 360 degrees, right? A full turn. So whenever it comes to just looking at it, we know that every single time we move one quadrant, we know that moving one quadrant always is 90 degrees, right? So if we wanted to describe this rotation that's going on right here, we know that it's going from here to there, right? And so if we wanted to look at the degrees, think of it. We started here, we moved to here. So literally, if we started here, we just moved one quadrant, right? We changed just one. Because if we start here, this would be 1, this would be 2, this would be 3, and then 4 would be back where we started, which makes sense because there were 4 quadrants. So every single time you move 1, that's always 90 degrees automatically, right? So since we started here and moved here, that's automatically 90 degrees. And then just look at what direction. We see that it went this way to that way. That's the direction of a clock. So it would be 90 degrees clockwise. Right? 90 degrees clockwise. Now, again, some people are going to say, you know what? I rotate it this way. Other people are going to say, you know what? No, I wanted to turn it this way. Which is fine, because in the end, they're both right. If you want to turn it this way, you could. If you wanted to turn it this way, you could have done that as well. So there is another way that you can describe this, right? So first and foremost, if we're going from here to there, start thinking, right? We start here. Every time you change 1, that's 90, right? So it's going to be 90, 180, 270, right? So 270, and if we look at the direction, it went the opposite direction of a clock. So it would be counterclockwise, right? Counterclockwise. And that's the first thing that we always have to see. If you then look at the numbers even more so, we see it. We have 90, we have 270, right? 90 and 270, we know that it's right because if we add them up, it's going to give us 360 and it gives us our full circle, right? That's why they're both right. 270 and 90 gives us 360, a full circle. So whenever it comes to describing rotations, there's always 2 ways you can do it. A clockwise way and a counterclockwise way. But always remember, every single time you move one quadrant, that's always 90 degrees, right? So now looking at that, we've described the rotation. We know directions that we can go. We know that each quadrant is 90 degrees. We know that a full turn, a full circle is always 360. But now, what we're going to do is we're going to try to figure out what the coordinates are. Because whenever you have a rotation, something happens to the coordinates, right? Always something happens to the coordinates. And I do want to show you, I'm going to use the same figure again. I'm going to do this triangle right there, right? I'm going to call that F. And I'm going to go back to what we had, all right? I'm going to call this one F prime, okay? And I'm going to give you a coordinate. Let's say that this one is 1. Let's call that one, let's call that one 2, 7. Okay? Let's call that 2, 7, and then we'll figure that one out, right? So we're going to get to this. But whenever it comes to this, again, there's certain rules that whenever you do rotations, certain things always happen, right? So again, if we wanted to figure this out, we would have that rotation that's going on, right? Actually, let me get rid of this just because it's going to be more confusing for you if you would actually do it this way. So we saw that one. We had a rotation of 90 degrees, right? Then, if we were to have this, let's say we were to turn it this way, right? This would end up being F prime, let's say, if we had that. Again, if you were to turn it this way, that would be, starting here, 90, 180. So this point would end up going there. The one we had would end up going from there to there. If we were to rotate it 270, this coordinate would end up there. And so what we're seeing is every time there are rotations, something is happening to that coordinate. That coordinate's always moving around, right? And so there's certain rules when it comes to rotations, right? There are certain rules for different rotations, right? Different rotations. And there are 3, which I'm going to give you, and then again, we're going to go over it. And then again, it can look complicated, but in class there was a video that we did play. Hopefully you guys were in class to help you out. So we have a 180 degree rotation, right? We have a 90-degree counter, right? And if we have 90-degree counterclockwise, it's the same thing as calling it 270 clockwise. Because again, whenever you have rotations, each one can be represented two different ways, right? So we have that, and then we had 270 counter, right? So there are rules when it comes to, 270 counterclockwise, which is the same thing as saying 90 degrees clockwise, right? So again, always be careful, guys. Just always be careful what we're working with. Remember, 90 degrees counter is completely different than 90 degrees clockwise, right? But we're going to focus on just the ones for counterclockwise, just because if we keep it uniform, it makes it a lot easier, right? So there's a rule that whenever you have a 180-degree rotation, the easiest thing happens, right? And we're going to write in coordinate notation, which starts x, y, goes to. So whenever you rotate a figure 180 degrees, all that happens to the coordinate or the signs change. If it's a positive, it becomes a negative. If it's a negative, it becomes a positive, right? And so if all we're doing is changing the signs, if we have x, y, it's going to become negative x, and it's going to become negative y, right? Again, whenever it's a 180-degree rotation, easiest thing in the world, just change the signs automatically, regardless of what it is. Doesn't always mean they're going to be negative. It just means that if it's a negative, it's going to become a positive, right? If it's a positive, it becomes a negative because, again, negative and a negative becomes positive. So 180, always change the signs. The 90-degree counter is the one that some people are going to have issues with. The 270 counter is the one some people are going to have issues with, just because you guys aren't used to seeing what happens, right? So again, we'll look at it this way, and then I'll explain. Again, all these coordinates are always going to go a different way. When you rotate a figure 90 degrees counter, what happens is, instead of having x, y, the first thing that happens is they flip, right? So instead of having x, y, you're going to have y, x, right? It's the very first thing that happens. Whenever you rotate it 90 counter, you flip the order. So instead of it being x, y, you're going to flip them. But then what also happens is the first term, that y changes, right? So always remember, whenever you rotate counterclockwise 90 degrees, you're going to flip them and then change the first term, the sign. Again, same thing, always the opposite sign. What happens when it's 270-degree counter is, again, instead of having x, y, you're going to flip the order, y, x. And then now, instead of changing the first term, we change the second term, right? So always remember, if it's 90 degrees counter, you flip them, change the first term. If it's 270 counter, you flip them, change the second term. And then when it's 180, it's easy. You just change both signs, right? Again, this can be confusing. Not so much the 180, but the 90 counter and the 270 counter. Again, 90 and 270 counter, always flip them. And then depending, if it's 90 counter, change the first sign. If it's 270 counter, change the second sign. And I'm going to show you though, because even though it does seem a little intimidating, it's not as difficult as you may think it is, guys. It's just getting in the hang of it. You know what I mean? It's just being able to practice with it. So the first coordinate, let's say that the pre-image that I have, let's say that the pre-image that I have is going to end up being 270, right? So our pre-image, let's call it B, is going to be 270, right? And then what I want you to do, I want you to figure out what the coordinate's going to be for 180-degree counterclockwise, right? What's it going to be when it's 180 degrees counter? What's it going to be when it's 90 degrees counter? What's it then also going to be when it's going to be 270 degrees counter, right? 270 degrees counterclockwise. And again, counterclockwise, always remember, guys, goes the opposite direction of a clock, okay? But again, it's just getting the hang of it. It's getting used to it to see it. Now, if it helps you guys, again, label your x, label your y, right? We know that that's our x. We know that that's our y. And if it helps you, just label them, guys, because going forward, it does help sometimes to see it. 180-degree counterclockwise, always remember, guys, for that, we don't have to change the order, but all you have to do is just change the signs. So if it's a positive 2, it becomes negative 2. If it's a positive 7, it becomes negative 7. That would be it, right? That would be our B prime. Because if that's our pre-image, that's our image, right? So again, when it's 180 degrees, regardless of the direction, right? 180 goes one way or another, lands in the same spot because it's midway. If it's 180 degrees counter, just change the signs. If it's 290 degrees counter, remember, when it's 90 degrees counter, the first thing we have to do is flip them. So instead of being 2, 7, it's going to be 7, 2. And then when it's 90 degrees counter, you always have to change the first sign, right? The first term. So the first term is 7. Since that's positive, we're going to make it negative. And that would be it. Again, just flipping the order and then changing the first term. When it's 270 degree counter, again, the same thing. We're going to flip the order. Instead of being 2, 7, it's going to become 7, 2. And now instead of changing the first term, whenever you rotate 270 counter, we always change the second term. If the second one is positive, it's going to become negative. And again, that's it, guys. It looks confusing sometimes. It can seem confusing, but always remember, it is that simple. When it's 180, just change the signs. 2 positives became 2 negatives. When it's 90 counter, you flip them. So 7, 2, and then change the first term. And then when it's 270 counter, you flip them again, change the second term, right? Let's just do one more just to get you guys a little bit more practice with this, right? And now I just want to give you guys a negative just to make sure that you guys feel comfortable with working with the negatives and these rules, just to see what happens, okay? And then the other coordinate, let's make it R, right? Let's call R1 negative 4, right? And then again, we're going to figure out the coordinates just like we did. Let's make that first one again. That's our X. If it helps you to see, the second one's our Y. So again, 180 degrees counterclockwise, always change the sign, right? If it's a positive, it becomes a negative, right? And if it's a negative 4, now instead of being a negative, it's going to become a positive. Always change the sign. Positive becomes negative, negative becomes positive, right? When it's again, 200 and 100, when it's 90 degrees counter, again, I just always go step by step because it makes things easier. First thing you do, flip them. So instead of being 1, negative 4, it's going to be negative 4, 1, right? And then, just to make it easier for us, you see it. We have 1, negative 4, right? First thing we did, we flipped them. And now, when it comes to 90 degrees counter, you change always the first term. So right now, seeing this, we see that our first term is negative. So if the first term is negative, we're going to change it. Opposite of a negative becomes a positive. So instead of having negative 4, 1, it becomes 4, negative 1. Because again, we flipped them, right? And once we flip them, we change the first term. The 4 was negative, so we changed it to a positive. When it's 270, same thing, right? You're going to end up flipping them. So instead of being 1, negative 4, it's going to become negative 4, 1. But now the rule for that is when it's 270 degree counter, we change the second term, right? The second term is 1. So that positive 1 now is going to become negative. Okay. Always remember, guys, just getting comfortable with those rules. If you need extra help, feel free to ask, okay? Take care, guys.